Let's have a look at part A and B in exercise 1 on page 85. So this is page 85. Here we are going to look at two infinite series, and we want to know, are they geometric or not? And if they are geometric, are they going to converge or not? So two questions really to answer. So this is the first time we are just starting with the expression, the sum for our infinite series. And so we need to get a feeling for what really are the terms in this series. And so let's just write it down. Let's just write down what happens when n is equal to 0, and then what happens when n is equal to 1, when n is equal to 2, and so on. So when n is equal to 0, I have 2 to the 0 plus 1 divided by 3 to the 0. And you can see that that is 2 to the 1, that is 2. I'm going to write down both of those lines. I'm going to add on to both of those lines so that we can see the details and then also see the value simplified. So this is what happens when n is equal to 0. Let's add the term when n is equal to 1. When n is equal to 1, we have 2 to the 1 plus 1 divided by 3 to the 1, and that is 2 squared over 3, that is 4/3. Now, for the next term, we have 2 to the 2 plus 1 divided by 3 squared, and 2 to the 2 plus 1, that is 2 cubed, which is 8. And in the denominator, we have 3 squared, which is 9. Let's do one more. When n is equal to 3, we have 2 to the 3 plus 1 divided by 3 cubed, and that simplifies to 16 in the numerator and 27 in the denominator. So we get 16/27, and we could keep going like this, but I think we have enough information to determine if this is geometric or not. So when you're looking at the terms, I'm going to change the ink color. So the first term, that is our value for a. Remember that a geometric series is of the form a r to the n, where n goes from 0 to infinity, and where a is the first term. So a in this case is 2. So we have a is equal to 2. And r, how do we find r? R is the common ratio. So r is the value that we need to multiply the first term by to get the second one, if it indeed is a geometric series. So we need to know, is there a number that we can multiply the first term by to get the second, and then does that same number work for the next term and the next term? And so to go from 2 to 4/3, we need to multiply by 2/3, because 2 times 2/3 is 4/3. And now, does that work for the second term? What happens if we take 4/3 and multiply by 2/3? That is 8/9. Oops, sorry. We multiply by 2/3 to get from 4/3 to 8/9. And then multiplying by 2/3 again gives us 16/27. So we can check that, yes, indeed, we have this common ratio, r, that is equal to 2/3. And so checking up in our definition and facts box, we learned that a geometric series converges if r is between -1 and 1. And in our case it is, because 2/3 is between -1 and 1. And we can go up to our box again and remember that the value of the geometric series in this case is a over 1 minus r. So we have this formula to tell us what the value is And so now we can come up with our final we can come up with our final answer and get a, which is 2, divided by 1 minus r, which is 2/3. And when you simplify this, you get a value of 6. So in this case, our geometric series converges and the value is equal to 6. So our conclusion, it is geometric and it converges to the value 6. For example B, we're going to start the same way. We are going to first write out the first few terms of our series. So when n is equal to 1, I have 1 over 1 squared. When n is equal to 2, I have 1 over 2 squared. When n is equal to 3, I have 1 over 3 squared. When n equals 4, I have 1 over 4 squared, 1 over 5 squared. So I'm adding up all these terms. And so simplifying, we get 1 plus 1/4 plus 1/9 plus 1 over 16 plus 1 over 25. And so our question is this a geometric series? So is this geometric or not? We would need a common ratio. So geometric or not, the question is there a common ratio? To get from the first term to the second, I would have to multiply by 1/4. But to go from 1/4 to 1/9, whatever it is, it's not 1/4. And so that already is enough to conclude that no, there is no common ratio. And so that leads us to conclude that this is not a geometric series.